This problem can be solved in 3 ways, ranging from easy to medium to hard. Let's give a trial. In the easy way, you just go with what we call the brute force. The word brute force means to try every possible thing. So one idea here is to try every couple of indices, to try every possible range. And then for every one of them, we will use the is increasing function that we implemented before to judge if this sublist is increasing or not. This way we solve the problem. But this is 3 nested loops. This is ON cube algorithm. The advantage is that it is easy to write, it is easy to read, but it is very slow. N cube operations. Now let's see how can we improve that. There are a lot of duplication of effort that's happening here. Specifically, let's say that you are at index 1 with 5 and index 2 with 7. Let's say that 3, 5, 7 is increasing already. Now, if the next element is 9, then again it is still an increasing sequence. What happens here is that we keep starting from scratch every time to judge the sequence is increasing or not. But if you know that it is increasing already, just check the next element if it will be more increasing or not. So the idea here is you will start from some index here for every index here, and every time you keep going as long as the list is increasing. So you ask yourself if this index is better than the previous index or not. If so, then we just found one more sequence starting from the start index to the index 2. Keep going, keep going, keep going. Once the index 2 become like this is false, then we know that this list starting from index 1 isn't increasing anymore. So the moral of that is start from index, keep going, and as long as it is increasing, then it's actually a valid sequence. Once it isn't, then break and start from the new index here. This is the moral of that. Now, if we would like to move that from just n square to something that is just linear, this is a bit hard. Take it easy if you couldn't get it. We removed from the 3 nested loops a lot of duplication in the 2 nested loops. We will remove also a lot of duplication in here to that guy. The idea is as following. Let's say that we started at some index and we kept increasing till we know that 1, 2, 3, 4 is our maximum sequence of increasing length. The moral of that is all of the subsequences inside 1, 2, 3, 4 are actually valid sequences. So all of them are increasing. So if you got this sequence, you then need to try, like for example, we tried in the previous code 1, 2, 3, 4 as subsequence, we added 4 times. Then we try 2, 3, 4 and add 3. Then we add 3, 4 to add 2, and we add 4. All of them are actually increasing. So once you got one increasing sequence, we know that there are 4 times 2, 4 times 5 over 2 valid subsequences from the beginning. So we didn't need to do all of that. So the moral of the idea is start from an index, and as long as the previous index can be increased, keep increasing it, keep increasing it. With every step, we add the current length, which represents the current sequence that we have. Once the sequence isn't increasing, we just make our current length equal 1. Let me back to this example here. Let's see here a good example. Yeah, let's say that we have 1, 2, 3, 4 only. So I can maybe I can write an example by myself here. Let's have something like 10, 20, 30, 40, and then let's say after that we have 2, 5, 7, and let's say we have 0. So the code goes as following. We have 10, keep going, 20, keep going, 30, keep going, 40, keep going. So we need now to add all of the 2 is less than 40, so it should now break here. But the idea is as following. At 10 we are adding the 1, at 20 we are adding 2, at 30 we are adding 3, at 40 we are adding 4. So we added 1, 2, 3, 4 subsequences, all of that. Why? Because at 40 all of them are valid sequence ending at 40, and at 30 we added 3 because all of the subsequences are valid at 30, and so on. So we added 1, 2, 3, 4 for these 4 numbers. Starting from 2, we made it the length again 1. At 2 we added 1, at 5 we added 2, at 7 we added 3, because we have this all of valid sequences now. At 0 we started again from sequence 1. That's all.